So let's go over this profit function problem. The one thing you want to keep in mind is that profit is your revenue minus your cost. Hopefully your revenue exceeds your cost, but it's not a guarantee. So I've given you those two functions. Here's your revenue, here's your cost. When we subtract these, now notice I put them in parentheses. And Layla, you wanted parentheses around both of them, so I did parentheses around both of them. We don't really need parentheses around this one because it's going to get multiplied by, essentially 1. There's nothing out in front of this. So I just drop the parentheses here. What you have to be careful about here is that this negative distributes itself to both terms. So a negative of a negative gives me a positive 4x, but a negative of a positive 250 gives me a minus 250. And it's very easy to forget that second negative sign, which is why I put these parentheses around this to encourage you to distribute that negative sign. Now when we do, we get this kind of a function, negative x squared, combined like terms, gives me 100x minus 250. Now you can graph that. Hopefully you're going to be using Desmos or a graphing calculator. It's going to look like this. Some points of interest. First of all, most importantly, is the vertex. What's that vertex point telling me? It tells me two things. Can you tell me what those two things are? Yeah. The number of flat tires that I need to fix in order to make a profit of $2,250. So there's two things there. One of them comes from the context of the problem. Bike store fixing flat tires. X is the number of flat tires here for us. Yes, Layla. It might be the window that you have. I'll take a look at it. But the windows that you have can make the graphs look different. For instance, I can make this graph look really flat, even though it's the same graph. That's because I've changed the scale on the x and y axis. Notice that here it's going up to 10,000. Well, this still only goes up to 2,250. But if I change the scale on the y-axis, I can make this graph look really, really tall. If I change this on the x-axis, again, I can make things look really very narrow. Just kind of depends on your choices there. All right. Anything else here? There's a couple other points of interest that I should mention. At what point do you start turning a profit? What has to happen with your profit? In order for you to be profitable, your profit should be above 0. So the break-even point there is around, probably 3. All right. At 2.5, you can't fix 2.5 tires, so you're going to go to the next one up. So it'd be 3 would be your break-even point. You have another break-even point over here. After so many, then people are bumping into each other. You need to expand your facilities. So at that point, you're no longer profitable. The model makes sense to a point, and we're fine with that. The things you should get out of this is being able to find the maximum height here and understand that at 50 tires, you're going to make a profit of $2,250, and that you need to sell at least 3 tires in order to be profitable. Questions on that one? I'll let you draw on the graph at leisure. Let's go back over a couple things here to kind of finish things up. I'm not sure we got around to this last one here in terms of factoring this and or using the quadratic formula. You can do both to solve this. And of course, you've got Desmos along for the ride. Now, 70 is not a really bad number. It's not like some multiple of 12 where you've got if this was 72, there'd be a lot of numbers that go into 72 evenly. There's not too many numbers that go into 70 evenly. Can anyone think of 2 numbers that go into 70 evenly? 7 and 10, right? And well, what's 7 plus 10? 17. Wow. X plus 7 times x plus 10 equals 0. So what does it give you for your solutions to this problem? Remember, you want to change the numbers here, change the signs here. Now, if you actually did it all the way out, it'd be x plus 7 times x plus 10 equals 0. You're multiplying two things together and you get 0. So one of these has to be a 0. Now that doesn't work with any other number. If you multiply two things together and you get 12, doesn't mean one of them is 12. But if it's 0, then one of those two things you have to multiply together is 0. So either negative 10 or negative 7. Nice. If you're running decimals, then you get a little bit of a perk here, right? Let's shut this graph off. Plug in y equals x squared plus 17x plus 70. And I need to zoom in over here. If you hit the home button, sometimes that'll help out. That brings you back to a screen of negative 10 to 10. And we can click here and see that we've got roots at negative 10 and 7. So there's your solutions pretty quickly. If you started out with the graph and said, hey, I know I got solutions at x equal negative 10 and x equal negative 7, x equal negative 7, then I can rewrite each of these by adding 10 to both sides. If I add 10 to this, I get x plus 10. What do I get if I add 10 to negative 10? 0. If I add 7 here, I get x plus 7 equals 0. So in other words, that's my factorization. X plus 10 times x plus 7. So if you've got the roots, then you can get the factorization. So if you're not good at looking at these things and going, hey, I don't know how to factor these things, you've got another way you can work on this. Now there's one last way that you can work on solving this quadratic equation. Suppose you didn't have Desmos, suppose you weren't good with your graphing calculator, you could still do this. What's your last best hope if you can't factor this? Other than Desmos. Quadratic formula. So we've got x squared plus 17x plus 70 equals 0. And let me just put in a nice friendly 1 out in front here, because that's going to be our a in the quadratic formula. So we're going to have ax squared plus bx plus c. I can see somebody listening to the audio on this and going, what was that clunk? It was me throwing my pen because it's out of ink again. So let's fill in kind of a blank quadratic formula. It's going to be negative of b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Now what's your 2 free points on the exam? What are you going to do for me? Yeah, you're going to write down the quadratic formula. So there's 2 freebies. Negative 17 plus or minus the square root of 17 squared minus 4 times a, which is 1. So I'll put that 1 here and here over, it's going to be 4 times a times c. So that last one's going to be a 70. I'll put that in here. And you can use a graphing calculator or just a regular calculator to do this kind of stuff. One thing that you might want to do is just figure out what this thing is underneath here. Maybe save yourself all that work. You don't have to get really tricky and plug in the formula completely. Let's just find out what's underneath the radical. So 17 squared is 289 minus 4 times 1 times 70 is 280. Whoops, how about a minus there? Minus 4 times 70 should give me a 9. So there you go. That's a little bit easier now. So I'll just put plus or minus the square root of 9 over 2. What's the square root of 9? 3. Now do yourself a favor. Just slow down for just a minute and take care of the positive case and the negative case. So the positive case is negative 17 plus 3 divided by 2. The negative case is negative 17 minus 3 divided by 2. This gives me 14, give me negative 14 divided by 2 gives me negative 7. This gives me negative 20 divided by 2 gives me negative 10. So there you go. We have spent a fair amount of time on the quadratic formula. I wouldn't be surprised if you had to solve one with the quadratic formula. Hint, hint, nudge, nudge. Do you want to practice one more quadratic formula one? I'm thinking about putting an extra credit question on the test for something like our little baseball problem. Where was that? 9. Here you go. Solve this with the quadratic formula. Ooh. Where that's equal to 0 would be a little bit more than 404 feet. I don't know. I'm not seeing any takers. All right, no one. So, all right, but do expect to use the quadratic formula for one of these. I'll make sure the numbers work out pretty nice. These have worked out pretty nice because the term underneath the square root has been a perfect square. You've been able to take the square root of that. But I hope you see the interplay between all three of these things. We looked at the graph, got these numbers, found the corresponding factors, and hey, we factored this polynomial. Or you could factor it just by looking at these numbers. Two numbers that multiply to this and add to this. There's your factors. Solve and get your roots. What's the quick way to go from here to here? Do I need to do all this stuff in between? How are you going to go from here to here? What's the trick? Change the sign, right? So just like back up here, you got solutions at 6 and 1. Or up here, negative 2 and negative 7. And finally, what's the last one? What are the solutions on this one? 3 and negative 5. Beautiful. You're in good shape.